This is my propeller clock using a picaxe 28X X2 picaxe chip and a DS1307 clock chip. I'm not going to spend too much time explaining it now, but I'm going to show you using another little camera, which is this little thing. For some reason this seems to work really well when it comes to filming it, whereas video camera that I'm using now doesn't film it. For some reason it's due to the, I don't know, the frame rate. This records at a, well, still 30 frames a second as standard, but it just causes it to go in focus and out of focus all the time and jumps and jitters and everything. For some reason the video camera don't like it, so I'll be using another clock. Anyway, I'm showing you how it works. This is my propeller clock. I'm going to turn it on with my little remote control that I quickly bodged up. It's just to send one signal just to turn the clock on and off. I'm going to make a full remote control and everything. This is just for testing purposes at the moment, as I've only just completed the clock and I'm going to be doing a remote later. So if I can successfully get these wires connected properly, so to turn it on. Hopefully you should be able to see this, because I can't actually see what I'm filming because I'm using a small little spy camera. For some reason this seems to work on the propeller clock really well. The video camera, it keeps pulling out of focus and everything. You can see we have time. This has just gone 10 to 10. I don't know if you can see that. Well, you can see that one. Now we have date. I plan to use the infrared remote for changing settings, such as so you can hold it on date or time or temperature or even text. At the moment it's just, I just programmed it to cycle through at the moment because I haven't got the remote working. Well, not working, I haven't built it. But it does work, as you can see I just turned it on. And the one on the clock does work as well. I'm also going to use the infrared remote for changing text. The text has been preset on the chip. I programmed it to say Decandy's propeller clock, but using the remote I should be able to cycle through the letters and choose which characters I want to make up words and, you know, full length messages. It's something I'll add later on. I'll probably release a new video when I get that working. And there we are, it just leaps through that back over, this time keeping the outer ring on. Now if this successfully works properly, I should be able to turn this off. However, it can be a little dodgy. For some reason it doesn't like picking up the signal. It's possible to turn it off, it's just being wires on this breadboard is very dodgy and sometimes it doesn't actually work, and because obviously infrared is invisible to the naked eye, I can't see whether it's on or not. And this camera doesn't have a little screen, as it's a little spy camera, so I can't see whether I'm actually sending a signal. We've got some little problem amongst the infrared. I think probably one of the wires are loose or something, but it does turn off. You can see I turned it on earlier, it should turn off, but if I had two hands to do this I could fix it. At the moment I have to use one hand to hold the camera. But yeah, so you have it, a propeller clock working. I'll probably release a new video when I have the full remote working and everything. That you are wanting to know, because I'm bound to get some comments and you'll be pretty interested. Let's take this out of here for now. This is all the works. Now this is a pick chip. It's actually a pickaxe, which is basically a pick chip with a bootstrap loader and interpreter pre-programmed on it when you buy it. This allows for easy programming, such as using a little jack socket which connects the serial port with your computer, and you can write in basic code without needing to write a long assembler code and everything like that. However, I'll probably be programming if I make any other things in C, because pickaxe does prove itself to be quite slow, which is why I've had to use this resonator here. This runs at 32 megahertz. It's an 8 megahertz resonator, but it uses a 4 times pull to get to 32 megahertz. This little one here, this is a DS1307 real clock chip, and a little crystal for it, which is the 32768 kilohertz crystal. This does all the time calculation and everything like that, and this one reads from it. The advantage of this is I can use this little backup battery in here, which keeps the time ticking. As we speak now, it's currently keeping time, and when this is powered up, it will just read the time from here, from this chip here, without having to keep the whole circuit powered up. It's wastes a lot more energy, and this battery here would last, they say, about 10 years, but you probably get about 5 out or something, I don't know. And not really, it's quite cheap to replace. This is a coil for the power transfer. Basically it's an air gap transformer, bridge rectifier, capacitor, smoothing capacitor, and a 5 volt voltage regulator, plus a further small capacitor. And we have an infrared sensor and a thermometer chip, which is placed right there, stuck down. And here's all the LEDs. The last one at the end is blue, up to about, sorry, I can only use one hand here, up to about here. These are all separate. These can be turned on and off individually. The last lot down here are all joined together, so they can only be turned on or off as a whole row, because, well, I'm running out of pins on the chip, and it doesn't need to be, because this is only for drawing the entire hand. The top ones I use for text and everything, plus there's a further few down here that can be optionally turned on and off. And that's turned on by this transistor, which controls the rest of them. Now, for the base, we have a outer coil. This generates a magnetic field, which in turn generates a voltage in this coil, as it does here. And this is a fan for PC, brushless fan, as they normally all are, mounted on a semi-transparent acrylic plastic. And this is the back works. This is a 28X2 chip as well, and the only reason I'm using this is because it's got two pulse width modulation outputs, one for the speed controller fan, this one, and this one here, which is the connected to the base of the transistor. And this is a heatsink. However, it doesn't need such a large area, but best be safe than sorry. Small relay to turn the fan on and off from the chip, and a 5 volt voltage regulator, and the small infrared index LED. Now, the idea of having a semi-transparent bit of plastic is I can mount the LED at the back and leave the front completely clear. However, it does prove some problems because it's not actually bright enough. It just about gets through. Sometimes it can cause a little bit of joggy and jitter, because sometimes it fails to pick it up properly. And this chip also monitors the rotation. This is a 4-lead fan. This green wire is the feedback, which also comes on 3-wire fan as well. Sends signals to the chip, which counts the pulses it receives and adjusts the pulse modulation accordingly to keep the propeller spinning at a continuous speed. Therefore, I don't need to do no calculations on the actual arm itself. Oh, and there's this, which I made, which is just stuck on by a bit of Velcro like this, which basically means you can stand it up like a picture frame, and you can rip it off quite easily for a wall mount. I can mount it on the wall. I haven't got any brackets or mounting yet, but I plan to put one either here so it can be held up like that, or on the corner so it can be held up like a diamond shape. and all I need to do is move the index LED because that marks 12 o'clock. So if I move that there, then 12 o'clock will be there. And this, you can see, is quite easy. Bit of blue tack, so a counterbalance, and that slots straight in there like that. That allows it to spin. Got any questions, just ask me, and hopefully I'll get back to you. Now, majority of the time I don't usually come on YouTube, I don't usually reply to most comments, but I'll try and do my best with this one. But that's pretty much my repair.